Okay, on this page, this is going to be a review of Math 1 exponentials, and specifically talking about exponentials that include a percent in the problem. And when there's a percent in the problem, we have to do some calculations for the factor known as the multiplier. Okay, so let me just go up here and read what this is saying. Recall that from Math 1 that there's a multiplier or change factor in exponential functions. You can take any value and multiply by the change factor to get the value to the next term. So you always start with 100% of the original value because we begin with that original value. And if the function is decreasing, we subtract that percent decrease from the 100% to get a multiplier that shows the remaining value at each time. That'll be a remaining value of less than 1. And if the function is increasing, then we add the percent to the 100% of the original value. Along with its percent increase, we would use a decimal rather than as a percent as the multiplier. So when I taught this to my Math 1 students, I taught them as, a little formula called 100 plus the rate. And so you can see right here in these examples doing 100 plus the rate, 100 plus the rate to get a multiplier and then converting it into decimal form. So let's go practice a couple examples here and see if you can recall from doing this with your Math 1 teacher. So using the first, they just want us in A, B, C, and D, and E to show the multiplier work, not using it for anything in particular, but just getting the multiplier. So saying a 6.3 jump in the approval for the president, that means you have to know that that word means that this is an increase. A jump is an increase in the approval. So we would use the 100 plus rate formula, which in this case is 100 plus 6.3, which is a 106.3. But then we convert that number to a decimal by moving the decimal 2 times so we can get our decimal multiplier. Hang on, I was a little bit out of space here. So 100 plus the rate is 100 plus the 6.3. That makes 106.3. Then we take that decimal and we bump it left twice, getting our final answer of our multiplier in decimal form as 1.063. How'd you do? So when this is an increase, we use the 100 plus R. The next one is a 45% off sale. What do you think? Is that an increase or a decrease? You got it. That's my 100 minus R because it's taking some percent off. So we say 100 minus 45. That's going to give me 55, but then we need to move the decimal twice. And my final decimal multiplier will be 0.55. Okay, let's look at the next one. A 12.4% drop in the cases of the flu. You got it. That's the 100 minus R because there's a drop. So 100 minus 12.4, grab a calculator right now and do that one. Don't try to do it in your head. We have tools for a reason. Okay, how'd you do? Did you get the 87.6 from that? And then we move our decimal twice to get our answer for the decimal multiplier of 0.876. Okay, next is a 9.25 sales tax in Los Angeles. This is money that's being charged to us when we make a purchase. This is definitely going to increase the price of something. So we take our 100 plus that rate. We get 109.25. We convert it to a decimal by moving the decimal twice. 1.0925 multiplier. Try the last one on your own. Okay, let's see how you did. 200% increase. That's our 100 plus the rate formula. 100 plus 200, what? Yep. we get 300. We move the decimal twice. That leaves us with a multiplier of 3. Okay, so that was just some practice in our multipliers. Now we're going to apply it to a word problem. So writing the explicit and the recursive functions for each scenario, making a table for the first 4 values. Here we go. You need to have a calculator handy. Please pause this and go grab a calculator. There were 23 bacteria in the first hour with a 13.5% increase. So first of all, before I even start to make this table, I need to know what the multiplier is going to be. Since there's an increase in the bacteria, I have to do the 100 plus the rate, 113.5. I move that decimal twice, and that leaves me with a multiplier of 1.135. I'm going to use that in my table calculation over here on the side. So on one part, we have the number of hours. In the first hour, there were 23 bacteria. So down here is the number of bacteria. Okay, so let's go to 2. Grab your calculator and do 23 times 1.135. I'm grabbing my calculator, you're grabbing yours. You got it. 26.105. You could round that down to 26 or round it, accordingly. Multiply it again. 26.105 times 1.135. 26.629. And then finally, the fourth term, multiply it times 1.135. And so it asked us to get a table with the first 4 values. There's my table for the first 4 values. Pause this and go try C and D. I don't know why there's no B. That's weird. Sorry about that. Okay, growing by 47% is a 100 plus 47 or 147. We move the decimal twice. This is a 1.47 multiplier. Now we can go make our table. Company has a profit of 2 million and the profit is growing. So we're starting with 2 million. I'm going to make this number of millions in the bottom, and up here is number of years. So in year 0, there was 2 million. So 2 million times 1.47, 2 times 1.47 is 2.94 million times 1.47 again is 4.32 million times 1.47 again, 6.35 million. And that is my first 4 terms because we had a 0 term in this one. How'd you do? Pause the video, try the next one. Okay, this one is a $90 shirt at Nordstrom's, goes on sale, and next week with a 25% reduction. When it says reduction, it is subtracting the rate. And essentially it means that this shirt is going to be 75% of its original price. Move the decimal twice, we get a multiplier of 0.75, 75% of its original price. It's a pretty good deal. So on the top is going to be the number of weeks. And on the bottom is the price in dollars of the shirt. So a shirt at Nordstrom's goes on sale next week with a 25% reduction. So it's starting at time 0 at a price of $90. And then next week, it's going to be 25% less. So you're going to go 90 times 0.75. The shirt is now $67.50 times 0.75 again. It's now $50 rounded to 63 cents. And one last time times 0.75. It's now down to $37.97. See how I can write that to fit. Hang on. Does that look like a $37.97 written sideways? Okay. So what the heck is this? This is a review from Math 1 on percent multipliers. Just so you have this handy, this is going to come up possibly in this chapter. So we needed to make sure you recalled this from Math 1. Okay.